Hello and welcome to part 9 of Speranza Guesses the Methods exam. This series where I guess the methods exam so you don't waste your holiday and you do some study instead. I've just got back from another dog walk so we don't need this anymore. Let's do some maths. Okay, first question, tech-free multiple choice. Give yourself 90 seconds. Now I'm going to solve it in 3, 2, 1. Let's do it. Alright, there's a lot going on here. It's a probability density function. So we know that the area here is equal to 1. Alright, so this is a nice neat little rectangle here, and so we can solve the area of that rectangle. We can say that area is equal to length times width, where the width is equal to 1/6 and the area is equal to 1. Length times 1/6. You can solve that and you're going to find out that the length is equal to 6, which means that A is equal to 8. Okay, so if you're 8 because 2 plus 6 is 8. Alright, so I think one of the answers is 8, so we can get rid of that one because we don't want to know what A is. It says if A is greater than 2, so in other words if A is over here, what's the expected value of this probability density function? Because this is a probability density function, we can write it as f of x equals 1/6, because it's just a horizontal line. So 1/6 where 2 is less than or equal to x, which is less than or equal to 8, and 0 elsewhere. Okay, and now we want to find the expected value. So that's going to be equal to the integral of the probability density function, 1/6 with respect to x, but multiplied by x. So we need this x. So we're finding the integral between 8 and 2 of x over 6. That's going to be equal to x squared divided by 2. So x over 6 divided by 2 is x over 12. So we get x over 12, and we're going between 8 and 2. Doing that, 8 squared is 64. So we've got 64 over 12 minus 2 squared. We've got 4 over 12. 4 over 12. So that's equal to 60 over 12. Simplifying 60 over 12, we get 5, and that is our answer. On to the next one. Alright, last question, tech-free. Give yourself 90 seconds and give it a crack. And I'm going to solve it in 3, 2, 1. Here I go. So when it comes to finding this shaded region, there are a lot of different combinations of integrals that would allow you to find that shaded region. Even if I were to come up with an integral myself independently, I don't know that the integral that I come up with will actually be correct, or will actually be an option in this multiple choice. So instead what I'm going to do is go through each of these 5 in turn and think about whether they're going to give me the answer or not. Okay, first one, the integral of f of x minus g of x, that is the top function, and that top function is the top function throughout, minus the bottom function, and that is the bottom function throughout, between d and a. At first blush, that feels really good. We're finding the area between two curves between the extreme value and this value here. But wait, the area goes all the way to here. This isn't an area between two curves question, strictly speaking, because the area between these two curves, or this integral here, is finding the area between here and then here, from A to D. This question's a little bit odd here because of the fact that that x-axis is cutting it off. You can only really use this when you've got something a little bit neater, something a little bit like this area and this area. This question is not as simple as an area between two curves. The reason one of them is dropping below that x-axis before our terminals. So, no good here. For a similar reason, going between D and 0 won't work either. We're here, right? But if we were going between D and 0, we're finding the area between the two curves, which includes this bit here, and we don't want to include this bit. And this going all the way to D includes this bit as well. So that's not going to work either, B's bow. Okay, what about the next one? Still persevering with the area between two curves idea, because we've got the integral between b and 0. So the integral between this new, so they're saying, well, the intersection's important. The intersection's an important idea. So between b and 0, the area between the two curves. But again, that's finding this part here, and I don't want to find that part. So I'm almost certain that I can get rid of this. This next bit here finds the integral between c and b, and so between here and here, and it totally neglects this part. So I can get rid of all of, I don't like c. Alright, so that's down to d and e. What about d? The integral between a and 0, just of f of x. Okay, that's interesting. If I'm not considering g of x at all, the integral between a and 0 of f of x finds this portion here. Alright, that feels promising. Now I'm finding the area between the two curves from C to A. Alright, so that is going to find this part here. So I'm feeling really good about this. Let's look at the last bit. The integral of f of x between d and b. Oh dear. Alright, the integral of f of x, that doesn't consider g of x at all. The integral of f of x between d and b is all of that. So I don't know what's going on there, but I've found way too much area. I keep adding them all together. I haven't like flipped a terminal to make one negative or something, so not going to work. Alright, so by process of elimination, I know or hope the answer is E. If it's not, this is going to be a really embarrassing video. Let's see. E is the integral of f of x of this entire curve between d and 0. Okay, I'm happy with that. I'm finding all of this. So if I find all of this, and if I were to subtract the white stuff, then I have definitely found that shaded area. Let's see if I've done it. Subtracting g of x, alright, g of x is this curve here, so that's good news, between C and A. Between C and A, yes, that's that bit there. Boom, 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 boom. Excellent, the answer is E. Could I have done this a faster way? Yes. Would it take me 5 minutes in an exam? No, it absolutely wouldn't, because I'm moving through those really, really quickly as I puzzle through them. So I think in real time, what I just did takes about 90 seconds, which is good because it's a multiple choice question. Okay, on to the short response. Alright, so here we are, we're up to question 19, tech free. This is actually going to be the last question in this video because it is an absolute monster of a question. It's actually written by a student of mine, Kavindi. Shout out Kavindi. She puts together the most amazing, complex, unfamiliar questions. I just tweaked it slightly after she sent it to me, but this is good. 7 marks, so I'm saying 10.5 minutes, but honestly, if you're making progress, keep going because it's a really cool question with a lot of moving parts. Alright, I'm going to start solving it in 3, 2, 1, let's do it. Okay, so it's a probability density function, we've got that. This bit here says all watermelons that weigh more than 13 2/3 kilograms are moved to a separate batch. And then it says determine the probability that at least one watermelon in the box will weigh more than 15 1/3 kilograms. So if we're going to find the probability of a watermelon that's been put into that box weighing 15 1/3 kilogram, we're going to need to know two things. We're going to need to know the probability that a watermelon gets put into that box in the first place, and we're going to have to know the probability of if something is in that box, what is the probability of it being 15 1/3 kilograms. So, first step, the probability of it being in that box. Here's our first line of working. The probability that x is greater than 13 2/3 is equal to the integral between 17 and 13 2/3, a function with respect to x. Okay, so now we're going to have to be able to integrate this function. Now we're going to integrate it and put it there. I just wanted to mention that 17 and then this 13 and 2/3, mixed numbers, horrible to deal with. Let's convert that 39 plus 2, 41 over 3. Okay, so integrating this thing here, we're going to get pi on 20 out the front. It'll change, but whatever. That sign's going to become negative cos when we integrate. So now that we have that, we need to take the derivative of the thing in the brackets and divide our coefficient by it. So what's the derivative of pi bracket x minus 7 on 10? Well, let's rewrite that. By expanding the top of it, I can write it as pi x minus 7 pi over 10. I can do a little bit more, divide both by 10. And what this says now is pi on 10 x minus 7 pi on 10. So the derivative of that thing in brackets is just pi on 10. And when I divide pi on 20 by pi on 10, I get a nice, neat 1/2. Alright, I'm doing all of this in one step because this is going to be a big question. Okay, so because I'm dealing with this integral here, I can actually move that negative 1/2 out the front because it's not going to affect anything whether it's there or there. The result's going to be the same. It's a little bit easier to work with if I leave that out the front. That way this thing in here is just positive cos and that negative 1/2's out there. Alright, let's sub in 17 and 41 on 3. Alright, so we've subbed those in there. Now, some interesting stuff. Negative 1/2. Cos 17 minus 7 is 10. So we've got 10 pi over 10, which is just pi. So we've got cos pi here. And you should know that cos pi is equal to negative 1. So that whole bit there becomes negative 1. Now, what about this thing here? Cos pi 41 over 3 minus 7 over 10. Well, again, let's jump out here and rewrite this bracket to something we can work with a little more. So we've got pi 41 over 3 minus 21 over 3. 21 over 3 is equal to 7. And 41 over 3 minus 21 over 3 is 20 over 3. And of course, 20 over 3 divided by 10 is equal to 20 over 30. That's going to be equal to 2 over 3. And so finally, all of this becomes cos 2 pi over 3. And of course, you know the exact value of cos 2 pi over 3 is equal to negative 1/2. So I have this nice neat little thing here, negative 1 minus 1/2. Okay, again, I'm saving space. You might put an extra line in here or something. Alright, so negative 1 minus 1/2, negative 1 plus 1/2 is negative 1/2. So I have negative 1/2 times negative 1/2. I get positive 1/4. What a neat little answer. Alright, that's the probability of them landing in that box being more than 13 and 2/3. Now, if we're going to find the probability of them being 15 and 1/3 given that they are in the box, first of all we need to find the probability that they are 15 and 1/3 kilograms without the given part of it. So in other words, we're going to have to do another integral here between 17 and 15 and 1/3. So we're integrating between 7 and 15 and 1/3. Same deal as before, negative 1/2 out the front. 15 and 1/3 is 46 over 3. We're going to sub those two in there. Now we already know the 17 one is negative 1, so that's straightforward. And unfortunately on this fixed 46 over 3 thing, we're not going to get quite as lucky as we did before. If we jump out here, we can rewrite it as 46 over 3 minus 21 over 3, which is equal to 25 over 3. And then if we add in this divide by 10 thing, divide by 10, divide by 10, we get 25 over 30, which is 5 over 6. Alright, finally we've got this little pi in here, so if we're multiplying everything by pi times pi, we get 5 pi over 6. And you should find it relatively straightforward to find out cos 5 pi on 6. It is negative root 3 over 2. So we get a nice, well, not as nice as previously, minus, all of this becomes negative root 3 on 2. Alright, and that minus obviously becomes a plus. So, what do we end up with here? Well, negative 1/2 times negative 1 is positive 1/2, and negative 1/2 times root 3 on 2 is equal to negative root 3 on 4. I'm just going to put that as like a single fraction, which is 2 minus root 3 all over 4. Okay, what do I have? I have the probability that x is greater than 15 and a third, and I have the probability that x is greater than 13 and 2/3. So far so good. I need to know the probability that something is this, given it is this. Let's write it down in notation. So we're finding the probability that it's greater than 15 and a third, given it's greater than 13 and 2/3. And that's going to be equal to the probability that x is greater than 15 and 1/3, and intersection it's greater than 13 and 2/3, over the probability that it's greater than 13 and 2/3. Now, looking at this, the probability that something is greater than 15 and 1/3 and greater than 13 and 2/3 and greater than 13 and 2/3, that's just the probability of this here. If you're going to be greater than two things, you've got to be just greater than the greatest thing. Okay, so what does that look like? Well, this bit here is equal to just this bit here, which is equal to this here, 2 minus root 3 over 4, and we're dividing that by this bit here, which is what we calculated in the beginning, which is 1/4. Alright, 2 minus root 3 over 4 divided by 1/4, that's the same as multiplying by 4. These 4's cancel each other out. I get the very cute 2 minus root 3. So, what is that? That is the probability that a single watermelon in the box of 4 watermelons has a weight greater than 15 and 1/3. Unfortunately, we're not finished, because it says here, determine the probability that at least one watermelon in the box will weigh more than 15 and 1/3 kilograms. This question has shifted from a probability density function question to a binomial probability question now. We've got 4 trials, 4 things in the box. The probability of any of those ones being a success, being more than 15 and 1/3, is that number right there. And to top that off, we don't have a calculator. Now, the question says, determine the probability that at least one watermelon. That's at least one success. And you should have had practice with binomial probabilities to know that if you see at least one success, that's the same as 1 minus the probability of no successes. So, that's what we're dealing with there, that 1 minus the probability of no successes. So, 1 minus, we're doing 4 trials and we're getting 0 successes. P, now P is the probability of success on a single trial. And we know that the probability of success on a single trial is 2 minus root 3. Now we're raising it to the power of the number of successes we want, and we want 0 successes. And then we've got 1 minus P going in here. But of course P is not P. P is 2 minus root 3. So we've got 1 minus 2 minus root 3 to the power of 4. Alright, we can tidy this up a little bit. We've got 1 minus 4 choose 0 is just 1. So 1 times 2 minus root 3 to the power of 0, that's just 1. So this is 1 times this. So we're just going to be left with that. Bracket 1 minus 2 minus root 3 to the power of 4. Be careful, there's a bracket there. Alright, 1 minus 2, well that's minus 1, and then minus root 3. So this becomes minus 1 plus root 3. Okay, that is the probability of at least one success. 1 minus 1 plus root 3 all to the power of 4, or all of that bit to the power of 4. But unfortunately, the question says give your answer in the form a minus b root c. So somehow we need to look at this bit and simplify it. We've got a power of 4 there, and so we've snuck in a little known fact from Unit 1, binomial expansion. I've dived into my formula sheet and I found a formula for binomial expansion. So, equals 1 minus, and then we're going to do our binomial expansion in this big bracket I've created. So, what is our binomial expansion? Well, x plus y, in this case, negative 1 plus root 3, is going to be equal to x to the n. Okay, so the first one to the power of n. So negative 1 to the power of 4. Negative 1 times negative 1 times negative 1 times negative 1 is 1. We've got a nice 1 there. Now, on the other end of our binomial expansion, we're going to have root 3 to the n. So, root 3 times root 3 is 9. It's 3. And then there's going to be another one of those. So, root 3 to the power of 4 is 3 times 3, which is 9. We've got a nice 9 on the other end of this thing. It's positive. Okay, and that is positive as well. So we've got a 1 and a 9 there, that's 10. Okay, what about these middle terms here? Well, the next term needs to be n choose 1 here first. So that's 4 choose 1. Now 4 choose 1 is just 4. And then x to the power of n minus 1. So the first thing to the power of this minus 1. So negative 1 to the power of 3. Now that's negative 1, which makes our 4 not 4. It makes it 4 times negative 1, which is negative 4. And then a root 3 on the end. Root 3 is our y value right there. Alright, if you're not familiar with what 4 choose 2 would be, which is our next term, 0, 1, 2, 3, 4, 0, 1, 2, 6. So 4 choose 2 will be 6. And then we raise this to the power of 2, which is 1. So times 1, so in other words, just 6. And then we raise this to the power of 2, which is root 3 squared, which is 3. 6 times 3 is 18. Okay, our next one is 4 choose 3, and from here 4 choose 3 is just 4. Now look at the pattern here. In this one we raise the first term to the power of 4, to the power of 3, to the power of 2. This time we're raising the first one to the power of 1, so that positive 4 becomes positive 4 times negative 1, which makes it negative 4. And then we're raising root 3 to the power of 3. Now root 3 to the power of 3 is root 3 times root 3, which is 3 times another root 3. So 3 root 3 times 3 root 3. Negative 4 times 3 is negative 12. And I have negative 12 root 3. Now I'm expecting 5 terms here. I've got 5 terms here. Great. Perfect. I can now simplify that. 1 plus 18 plus 9, that's 28. And negative 4 root 3 minus 12 root 3 is negative 16 root 3. Okay, and now 1 minus 28 is negative 27. And 1 minus 16 root 3 is plus 16 root 3. And so our answer said give your answer in the question said give your answer in the form a minus b root c. A, negative 27, plus B, 16, root 3. We did it. So there's an awful lot in that question, and if you can do it, if you can follow it, you're doing well. What we did was a probability density function. To do that, we had to do some pretty freaky integrals. We also had to know about standard triangles, things like that. We had to do that twice. After that, we had to do some conditional probability. After that, we had to do some binomial probability, and then we needed to do some binomial expansion. Now, I did do that binomial expansion pretty slowly. If you're not happy with the way that I did it, you can do it a different way, right? You can instead say negative 1 plus root 3. I'm going to square that, and then square it again. You might prefer that to doing binomial expansion using that formula and using Pascal's triangle if you're not sure how to do that. If you're looking at this a little bit confused, negative 27 plus 16 root 3, seeing a negative in a probability, this is a number larger than 27. Only just though, negative 27 plus 16 root 3 as a decimal approximation is about 0.71 or something. Alright, that's enough on that question. Let's tick it off. So we did 2 tech-free multiple choice questions. We did a single tech-free short response. We're not going to go here. If you're feeling a little bit ripped off, don't be sad. External exams often only have 19 questions on them, and I'm kind of expecting it this year because they've been crunching us for time in previous years. So that's all the tech-free stuff for this series, I guess. Make sure that you go back and you make sure that you can do things like standard triangles. That's appeared in lots of questions, that you know your log laws, that you can spot those log identities like LNE, log base EE, or log base E1 and know what that means. Lots of tech-free stuff that gets put into these questions. All right, good luck.